Hello, welcome to today's session. In this session, we will be studying about tachyometry. In this video, we will be studying what is tachyometry and what are the instruments used for doing tachyometry, and also what are the different methods of tachyometry. So what is tachyometry? Tachyometry is a branch of surveying in which the horizontal and vertical distances are measured by angular observation using a tachyometer. The chaining operation is completely eliminated in this process. So this method is mainly used for preparing contour plans and traversing, and also suitable for hydrographic surveys, location surveys of roads, rails, etc., and also employed for conducting small surveys in which elevations are to be determined. And this is best suited when obstacles come across the line of survey in the form of some steep and broken ground or deep ravines, stretches of water, swamps, etc. Then in terms of precision, it is not very suitable. An accuracy of 1 in 1000 can be achieved if we are carefully handling the instrument. Now, the main instruments used in tachyometry, one is a tachyometer and the other one is a leveling or stadia rod. Now coming to tachyometer. What is a tachyometer? So basically this tachyometer is a transit theodolite which is fixed with a telescope having a stadia diaphragm. You can see what will be a stadia diaphragm looking like. So in these figures you can see there are some stadia hairs provided in addition to the central crosshair. Okay, so such an arrangement will be there for tachyometer. Different types of stadia diaphragms are shown in this figure. Now coming to the stadia rods used. Stadia rod is generally used for this type of survey, and it can be shown in this figure, and it can be folding or telescopic type. Up to 4 meter long are available, and this graduations will be really bold and very clear, and this least count of this stadia rod will be less than that of ordinary leveling staff, and it should be as light as possible. Now coming to methods of tachyometry. Before going into tachyometry, the underlying principle common to different methods of tachyometry is that we should understand that the horizontal distance between an instrument station and a point, as well as the elevation of the point relative to the instrument, can be determined from angle subtended at the instrument station by a non-distance set point, and also the vertical angle from instrument, vertical angle measured with the tachyometer to that point. So this is the underlying principle of tachyometry. Now coming to the different methods adopted for tachyometry, the main two methods adopted are the stadia system and the tangential system. We can see one by one. So what is stadia tachyometry? In stadia tachyometry, the basic thing is that it is using the stadia wires of the tachyometer. Okay. So in stadia system, the observations are taken with the help of the stadia wires of tachyometer. Readings on a particular staff are taken corresponding to all the three crosshairs. All the three crosshairs as shown in this diagram. So corresponding to all these three crosshairs, readings are taken on a staff, and the reading corresponding to the central or middle hair is the one used for finding the differences in elevation, and the one corresponding to top and bottom. Top and bottom hairs are used to find out the horizontal distance between the instrument station and the staff station. Okay. Now, there can be two methods under the Stadia system. One is fixed hair method and the other is movable hair method. Coming to fixed hair method, in this, as the name, from the name itself, we know what will be this fixed hair method. So, here the distance between the Stadia hairs is fixed. So, when a staff is sighted through a particular telescope, what happens? A length can be intercepted by the stadia hairs of the diaphragm, and the difference between those two will give the staff intercept, and from this value we can determine the distance from the instrument to the staff, so that horizontal distance can be measured from these two. Staff intercept, then staff intercept will vary with the distance from the instrument. So when the distance between the instrument and the staff station increase or decrease, correspondingly staff intercept will also increase or decrease its range. Then this method is the most commonly adopted method of tachyometry. Then movable hair method, now this method is rarely used, but anyway, in this method, the difference is that the stadia hair is not fixed as that of the earlier case. So it can be moved by means of micrometer screws. So what is fixed? Here some target will be fixed at a non-distance apart on the staff itself, and we will be adjusting our stadia hairs to view those two targets. Okay, so the variable stadia distance is measured, and from that we will be finding out the required horizontal distance. Now this method is rarely used. So fixed hair method is the one which is commonly used. Now coming to the principle of stadia tachyometry, you can see in the figure this principle is being sought out by using the conditions of similar triangles. All the triangles that we obtain in this tachyometry are considered to be isosceles and similar, as you can see in this figure itself. So in this figure, this E represents the eyepiece of the telescope, D represents the stadia diaphragm, and O represents the objective lens. Then this A dash, B dash and C dash are the readings corresponding to the stadia hairs, top and bottom stadia hairs at each staff stations. Okay, different staff station which are at D1, D2 and D3 distance apart. So the staff reading at different distances from the instrument will be actually proportional to these distances A dash, B dash and C dash. Okay, so all these are proportional to each other. This triangles will be isosceles and similar, and by solving all the similar triangles we can obtain the basic equation of the stadia tachyometry. So this principle of stadia tachyometry can be well explained from this relation, that is D is equal to Ks plus C, where K is termed as the multiplying constant F by I and C is termed as the additive constant F plus D. This F by I value will be, the multiplying constant value is usually 100, and additive constant value for external focusing telescope, the value ranges from 30 to 60 centimeter, but for internal focusing telescope its value ranges from 10 to 20 centimeter. It's really small, so usually it is eliminated. In order to make this additive constant 0, usually we will be including a special type of lens inside the telescope. It is termed as analactic lens. So that F plus D will be equal to 0. This equation is only applicable when line of sight is horizontal and staff is held vertical. So this is the equation which explains the principle of stereotachyometry. Now coming to the next method of tachyometry, that is tangential tacheometry. This method is used when the telescope is not fitted with a stadia diaphragm. So here it is not fitted with a stadia diaphragm, or we can say stadia hairs of the diaphragm is not used at all. So in this method, horizontal and vertical distances are to be measured, and some vertical angle measurements are to be done corresponding to the two vanes or two targets on the staff. So vertical distance is the one which is measured, and horizontal and vertical distances are to be measured. So there can be three different cases coming under this particular type of tachyometry. The case one is both the observed angles are at angle of elevation. Case 2 is one angle is in the elevation and other angle. Okay, case 2 is both the observed angles are angles of depression, and case 3 is one observed angle is above the line of sight and the other is at depression. So these are the three cases. For all these cases, we can derive the equation for RL of staff station. So you can see the staff station is represented by P here. Okay, so it is represented as P. Now, the RL of the staff station P can be obtained from this S, H and V. Okay, and the vertical angles are taken to this staff intercepts, the targets held on the staff. And the distance between A and B, vertical distance between A and B is termed as a staff intercept. The angles are also measured corresponding to those two hairs, and the distance corresponding to B is termed as H, and distance from the line of sight to B is termed as V. Okay, so RL of staff station P is given by the equation RL of the line of sight plus V minus H. So RL of the line of sight means the one corresponding to Q. That RL of this Q plus this distance V and minus H, that will give the RL of staff station P. Now in the next case, the RL of station P, you can refer to this figure. Here also H, S and V is marked, and all the two vertical angles are marked, and so RL of this ground point you can determine by RL of the line of sight. That means this height corresponding to Q minus V minus H. Okay, that will give the RL of the ground station. Now in the third case, how will you get the RL of the staff station corresponding to this point? How will you get the RL? You will get the RL of this ground point is equal to RL of the line of sight. That means the one corresponding to B minus V minus H. Okay, this is the case 3. So these were the three methods corresponding to the second method of tachyometry, tangential tacheometry. So hope all of you have understood this session. Thank you.